we're going to talk about what's called implicit differentiation. Implicit differentiation is when you don't have the ability to solve the equation for y. Implicit differentiation. So, for example, if I gave you 3x squared plus 4y minus 3x plus 8y squared equals 10. I told you to take the derivative of it. You know, ideally you'd be able to rearrange things so it said y equals something, and in terms of x's, so you had like a y over here and then a bunch of x's over here, and you could do the derivative like we've normally learned. You can't do that though. You got a y squared and you got a y. You're not going to be able to combine them. You know, if you square root this one, this will end up being the square root of y. That doesn't help you. So we're going to have to do a different method. What you're going to do is you're going to take the derivative of every variable. Take the derivative of everything. But if you take the derivative of a y, you're going to multiply by dy over dx. It's kind of like the du idea. It's really a chain rule thing that's happening. I don't want to get into too much of the theory behind it. I don't think that's really necessary, but it's basically a chain rule idea. So I would take the derivative, so I'm going to do this problem and like write out a step, do the problem, write out a step, do the problem. So the derivative of 3x squared would be 6x. The derivative of 4y would be 4. But I took the derivative of a y, so I'm going to multiply by dy dx. Derivative of negative 3x is negative 3. Derivative of 8y squared is 16y, but I took the derivative of a y, so I multiply by dy dx. The derivative of 10 is 0. Alright, then, our dy dx means derivative, so we want to solve for that variable. We want that variable by itself. So now it just becomes an algebra problem. I'm going to gather every term with dy dx on one side and put everything else on the other side. So if I did that, I've got 1, 2, 3, 4 terms. The two that have a dy dx are going to stay over here. The two that don't are going to move to the other side, but they would become opposite, because when you cross the equal sign, you got to change the sign. You know, like I'm subtracting this one, so it ends up negative. I'm adding this one, so it ends up positive. Then you're going to factor out a dy dx on the left only. There isn't one on the right, but just to make sure. So if I take a dy dx out, what's left here would be 4 plus 16y equals negative 6x plus 3. And then you divide. So if I divide both sides by 4 plus 16y, then my derivative is negative 6x plus 3 over 4 plus 16y. And the derivative means the same thing that it always does. It means slope. If you're asked to find the slope at a point, now you got to plug in an x value and a y value because you got two variables there. If I want to know where there's a horizontal tangent line, I set the top equal to 0. If I want to find a vertical tangent line, I would set the bottom equal to 0. Equation of a tangent, all that stuff still applies. We're just getting to the derivative a little bit differently than we normally do. All right, let's try a different one here. We'll try a different pencil too. So this will be a little tougher. I'm going to say, let's say 4xy plus x squared plus y squared equals 8. So the problem here, the thing that most people forget or have trouble with, is that this guy here is a product rule. You've got a variable times a variable. This is normal, that's normal. But this is product rule. So I'm going to treat it as 4x times y, where this is my first thing and this is my second thing. So the second thing is y. The derivative of the first thing is 4. I have not taken the derivative of a y at this point, so I don't put a dy dx. Plus the first thing times the derivative of the second thing. Well, the derivative of y is 1, but you took the derivative of a y, so you multiply by a dy dx. And then you just keep going like before. So that's going to be 2x. This is going to be 2y, but you took the derivative of a y, so multiply by dy dx. The derivative of 8 is 0. Now you've got 1, 2, 3, 4 terms again. On the left, the ones with dy dx are going to stay over here. The ones without dy dx jump to the other side and become negative, so negative 4y and negative 2x. Then you factor a dy dx out and divide by what's next to the dy dx, so what you'll end up with is negative 4y minus 2x over 4x plus 2y, which you could reduce. Remember, you can't reduce unless it's in all 4 things, so you can't take out like an x or a y or a 4, but you could cut everything in half if you really wanted to make this like negative 2y minus x over 2x plus y. You could. Also keep in mind that if you had done the problem, like if you had put the dy dx's on the right hand side, you would get this exact answer, except every sign would be negative. If every sign is negative, it's the exact same answer. Alright. Let me do one more of those product rule guys and we'll call it a day. Let's say 3y squared minus 4x squared y squared plus 4x equals 7. So 6y times dy dx minus the entire product rule. So this is like a negative sign issue. You could screw this up easily. This is product rule because I got one variable times another one. So it's the second thing times the derivative of the first thing plus the first thing times the derivative of the second thing, but I took the derivative of y, so times dy dx. Plus the derivative of 4x is 4, and the derivative of 7 is 0. Now I'm going to distribute that negative sign. And I know some of you can do this like in the same step, but it's easier for me to show it if I go through. I am rearranging these variables. Oops, that was the entire point, was that this would be negative. I'm rearranging the variables to put them in order. Like I just like it to go number, then x, then y. But this and this are the exact same thing. I don't care which way you write it. It's just in my brain, it works better if it's in this order, but yours doesn't have to work the same way. I'm going to keep the terms that have a dy dx in them over here. I'm going to move the other ones to the other side and change the sign. Then I'm going to factor my dy dx. And divide. And this would be like 8xy squared minus 4 over 6y minus, wait, this one is x squared y, sorry. And that'd be your answer. And you could cut all those in half. You can't take an x or y out of everything, that won't work, but you could cut them all in half and that'd be fine. That's it. So I put a worksheet with 6 of them on there. I don't even think I did any product rules on there. I think they're pretty big. No, I can't remember. But do those. We will take it a little bit further tomorrow.